Okay, so today we're going to be starting off with an absolutely fantastic topic. We're going to be talking about perpendicular and parallel lines. Now, this is something that actually becomes quite important in Year 12 because in Year 12 we study a topic called vectors. Now, when we start looking at vectors, we start thinking about how things move in three-dimensional space. Now, whenever you're talking about something moving in three-dimensional space, you start to want to think about when it's going to collide or if it's going to collide or how many times it's going to collide. So that's something that we can use or we can utilize this topic for to help us work out that sort of information. Now, perpendicular and parallel lines also feed in with this information to the side here. So we want to be talking about things that have multiple solutions, meaning that it's really the same equation. So here you can see that we've got that red line lying directly on top of the blue line. So when we see something like that, we're saying that it has multiple or infinitely many solutions because it's always touching. Essentially, the two things are the same line. If you look at these examples here, well, we've got y equals 2x plus 3 and 2y minus 4x equals 6. They are essentially the same thing. If I rearrange this second equation to look like this first one, so all in terms of y equals, first thing I would do is move the 4x across. Then I would divide everything by 2 to get the y on its own. Now, when I do that, this will become 2, and this one would become a 3. So I'd end up with 2x plus 3, which is the same as what you have in the first one. Or, more importantly, I would say that as they have the same gradient and intercept. Okay, so we're going to start taking some notes for this. So the first thing we're going to write is multiple / many solutions / infinite solutions, which is more commonly referred to as. Okay, so the key characteristics of identifying that is if they have the same gradient and intercept. So if they have the same gradient and intercept, we would say that it is infinitely many solutions. It's essentially the same line, they're on top of each other. If it has a single solution, or one solution, what we're looking at is what you've already examined in maths. We're looking for something with one point of intersection. So that means that they can really have anything. It can be any gradient as long as they're not the same. Has to be different gradients. Now, the intercepts can be anything as well. So different gradients. Any intercept. Okay, and the next one we're going to talk about is parallel lines or no solutions. So no solutions / 0 solutions / parallel lines. Now, if you have trouble remembering which one's parallel and which one is perpendicular, the easiest way to remember it is the parallel lines have the two lines running parallel in the word. Okay, you don't get that with perpendicular. So if we're talking about parallel lines, then we are saying that they have to be the same gradient but different intercepts. So over here, if you look at this expression, you can see that this one has the same gradient as that one, but the intercept values are different, meaning that they're always going to be separated. So same gradient, different intercept. Okay. Okay, so that is parallel lines, always moving, parallel, never touching. And then the next one, or the last one that we're going to be looking at is not really in one of these, but it is one that we're going to be examining today, and that is perpendicular lines. Now, perpendicular lines are lines at right angles to each other, meaning that they're 90 degrees, or they're separated by 90 degrees. So if I have two lines that are perpendicular, I can really quickly identify it in their gradients. And the way that I do that is because the gradient of the first one is going to be equal to 1 or negative 1 over the gradient of the second one. So if I had an equation that looks like this, y equals 2x plus 3, I don't care about the intercepts, they can be anything. A perpendicular line to this equation would be negative 1 over 2, x plus 3, or x plus 7, or x plus whatever. But that is the important piece of information. If this is a 2, then this is negative 1 over 2. If this is my equation, then this would be a possible perpendicular line to it. Okay, negative 1 over the top of it, which means that I invert these fractions. So that is a possible perpendicular line to this one. So when I get my equations in this form, it's pretty easy to tell which one of these it fits. The hard part is for you to remember this, because it is something that is going to be quite important to you. I remember it off by heart because we've done it that many times in Year 12. Okay, so let's start doing some examples. So let's say that we want to determine if the simultaneous equations are the same, parallel, or perpendicular lines. So determine if the simultaneous are the same, which is infinite solution, parallel, no solution, or perpendicular. Which would be one solution, but a funny gradient. Okay, so if this is, we'll call this example A. This is my first equation that we're given. X plus y is equal to negative 2. This is the second equation that I'm given. X plus y is equal to 7. We're going to rearrange into the form of y equals for both equations. So for our first one, the first thing I need to take across is this x. And when it goes to the other side, I'm moving the whole term so it becomes minus x. So y is equal to negative x minus 2. Now, this thing would currently have a gradient of negative 1 and an intercept of negative 2. Let's examine what happens with the second equation. X plus y equals 7. Move the x to the other side by subtracting it. State what you have left. Y is equal to negative x plus 7. So now we can start to think about what this means. Well, they've got the same gradient because they've got the same number in front of x. But they have different intercepts. So if I've got something that has the same gradient, means it's traveling along like that. Different intercepts means it's going to be parallel. or no solution. Okay, next example. So that was a pretty easy one. B. Okay, so if we're given this is our first equation, 3x minus 4y equals negative 2. And our next equation is given to us as 9x minus 12y equals negative 6. Okay, so again, I'm going to start by rearranging. For y equals. Okay, so we're going to start with equation 1. 3x minus 4y is equal to negative 2. Take the 3x across first by subtracting. So negative 4y is equal to negative 3x minus 2. Make sure your equal signs are lining up. Be careful with your working out. Now we can separate the negative 4 from the y, meaning I'm going to divide everything on this side by negative 4. So negative 3x minus 2 divided by negative 4. Now let's do the same thing for equation 2. So 9x minus 12y equals negative 6. Take the 9x to the other side. State what we have left, minus 12y is equal to negative 9x minus 6. Take the negative 12 to the other side by dividing everything. Okay, and now I can see that everything there has got a factor of 3. So I'm going to divide all of the terms here by 3 to get me y is equal to negative 3x minus 2 over negative 4. So now I can see that these two equations share that same gradient and they share that same intercept. So that must mean that they are simultaneous. So therefore, same gradient, same intercept, infinitely many solutions. Or another way I could say that is they are the same. Perfect. Okay. So that's all I'm going to show you today. Get started on the other questions. Remember, the only other one that we didn't examine is if we are looking at a parallel line. Perpendicular, the one at right angles. And remember, you would always identify that by looking at the gradient that's in front. Say it's A. And then its perpendicular line will be any value on the end here, but it'll be negative 1 over AX if it is a perpendicular line.